Imagine holding a miracle in your hand. Seriously, right now. Inside your body, trillions of reactions are firing off every single second, flawlessly keeping you alive. And outside? Massive industrial processes are busy forging the materials of our modern world, everything from life-saving medicines to the very device you're watching this on. Now what if I told you there's an invisible engine calling the shots on the speed, the efficiency, and even whether all this can happen at all? This isn't make-believe, this is chemical kinetics. Welcome. Today I'm exploring the unseen world of chemical kinetics, the science of how fast chemical reactions actually happen, and the amazing molecular dance that governs pretty much everything. It's a field that sometimes gets lost in the shadow of flashier scientific breakthroughs, but make no mistake, it's the unsung hero, quietly revolutionizing medicine, powering our industries, and holding the keys to solving some of our planet's biggest challenges. From the blink of an eye to the eons it takes for mountains to form, kinetics is like the conductor of chemistry's orchestra. So, let's get into this incredible invisible engine and see how understanding it is shaping your life, our world, and the future of humanity. So what is chemical kinetics, really? Simply put, it's the study of reaction rates. Thermodynamics tells us if a reaction can happen, if it's got the green light, energetically speaking. But kinetics tells us how fast it'll go. Think of it like this. Thermodynamics might say a boulder at the top of a hill can roll down, but kinetics tells you how quickly it'll zip down what might be in its way, or if it needs a nudge to get started. That nudge is activation energy, the minimum oomph needed for a reaction to actually kick off. Molecules need to collide with enough energy and just the right angle, like a key fitting perfectly into a lock, for a reaction to happen. Several things can shake up these reaction rates: concentration, temperature, physical state, and the magic of catalysts. More reactants, faster and more frequent collisions. Raise the temperature, molecules zip about, bumping into each other with more energy. Gases react faster than liquids, and liquids faster than solids, because their molecules move more freely. And catalysts? They're the chemical matchmakers, lowering the energy barriers and speeding things up without being used up themselves. Now let's bring this home. Inside your body, chemical kinetics is the very essence of being alive. Enzymes act as nature's catalysts, making reactions like digesting your lunch millions of times faster than they'd happen on their own. Metabolic pathways, nerve impulses, even the way medicines work, all come down to kinetic principles. And beyond biology, kinetics is a giant in industry. The Haber-Bosch process, for example, uses catalysts and careful control of reaction speeds to make fertilizer and feed billions. Plastics, batteries, catalytic converters, they all rely on kinetic control to be efficient, safe, and green. Looking ahead, chemical kinetics is at the heart of tackling plastic waste, clean energy, and environmental cleanup. Designing better batteries, cleaning water and air, or even making medicines more precisely, all rely on mastering the speed and control of chemical reactions. So, next time you marvel at a new drug, a sustainable material, or a breakthrough in clean tech, remember the silent power of chemical kinetics, the invisible engine driving it all. If you're fascinated by this and want more explorations into the science shaping our future, hit subscribe and let me know in the comments what kinetic breakthrough you're most excited to see. Stay curious, keep questioning, and I'll see you in the next one.